Awesome. Hi, my name is Mike Dvorkin. I am CTO and co-founder of Hedgehog. We are a small company that's trying to consumerize SONiC through use of Kubernetes. And today we'll talk about how to manage SONiC and networking with Kubernetes. To start, I want to say this. Networking was the original distributed application. But for some reason, we never really wanted to deal with it as such, and we always wanted to manage it as this special boxes that needed to be babysat and really cared for, and God forbid you misconfigure something, lots of things catch on fire. And SONiC is not an exception. SONiC is a great operating system. It was built on great principles, such as you take Linux, you put some things in containers, slap on top of Linux, and write some scripts, and you have a switch operating system. It's very nice, and it's modular. It's definitely the right start. But I think for SONiC to be used en masse, we need to build a controller model for it. And that controller needs to work, or needs to present the SONiC network as a fabric, right? And it should be a fabric of distributed networking applications rather than just collection of boxes the way things have been done normally in the world of network management. And the way it needs to work is that it's a managed fabric. It's controlling distributed applications that are running on top of a control plane. And that control plane ensures that applications and their corresponding configurations get delivered to where they need to run. In the case of normal SONiC, you have FRR. FRR is what is it? It's basically a piece of code. It's an app, right? And you can update it. You can deal with it just the way you deal with normal software, and you can distribute its configuration just the same way. There's nothing really special about networking applications that require special treatment. And this control plane should run on top of a lot of SONiC-capable devices, and not only SONiC-capable devices, it can run on top of anything. So you can have switches, you can have DPUs that run various functions, because DPUs, again, what are they? They're little computers sitting inside another computer, and they have a bunch of CPU and a bunch of memory, and they have network interfaces. And you have regular servers where you can run various networking applications, or observability functions, whatever. Right? And all those things are just pieces of software, and they can be configured and controlled and updated through a control plane. And this control plane already exists. It's Kubernetes, much to dismay of many people. Why the hell would you want to do that, some might ask? Because Kubernetes is bloated, scary, and it goes out of whack periodically. Good point, but it's better than writing something from scratch. And in my life, I built. I should. Yay! Now you can hear me. My thunderous voice. And I built a number of controllers in the past. And building controllers, while seems like an interesting activity, it's painful. And building a new one, nobody really asks for it ever. There are already enough controllers, even under Linux Foundation. There's Open Daylight that I think still exists, and all those things were built for kind of standard ways of thinking about networking, and were not designed for a kind of distributed app type of stuff. And Kubernetes is a lot more than just container orchestration. Kubernetes is basically a control plane. It's very extensible. It's very modular. It scales pretty well, especially for the normal network sizes. It's more than adequate. And it's a great tool for application and control planes, and infrastructure control planes. So you can stitch any sort of control mechanism out of it, and it's extensible through standard means. You can run your own resource definitions, you can write your own operators, and you don't have to hard code anything. It can manage not only just normal applications, it can manage anything, and that's a wonderful thing. And there are a lot of people who know Kubernetes. As a matter of fact, there are a lot more people who know Kubernetes than people who know SONiC or know networking in general. It's a fairly common thing today. And Kubernetes is everywhere. Like it's in public cloud. If you're deploying stuff in the public cloud, likely you're using Kubernetes already. Off-cloud data centers, most of the new stuff being deployed is based on Kubernetes. Like most of the edge stuff is Kubernetes, and now like the new emerging thing that's called distributed cloud, that's all pretty much like powered by Kubernetes. You can run stuff anywhere in Kubernetes. Kind of makes it happen, unless you're like really locked into the cloud services, which is always a challenge. So the new stuff like AI, ML, edge data processing, like the 5G applications, all this stuff is basically done with Kubernetes. And like most people who are like, getting into infrastructure now, like they have their teeth in the cloud. So like I have a 22-year-old kid. He ran things on Amazon for most of his life. I mean, most of his professional life, which is not very long, but. And then he decided to like set up a little AI lab on-prem, and he was horrified, the kind of things he had to do, especially in networking. He's like, Dad, like, you worked at Cisco, why is this? Like, this is horrifying. And the way people deal with things in the cloud, it's like a tip of the iceberg, right? You get to configure things like at a very high level abstraction, and like a lot of the complex stuff is somebody else's problem. It's like somebody else's magic. You know, you take it for granted. Once you move off cloud into the private environment, that horror becomes your life. You're basically facing this horrific reality every day. And for SONiC to be consumable, we really need to start thinking about how to provide UX that is very similar to how people do things in the cloud. It can no longer be like, I have to deal with all of this stuff. This is hard. And Kubernetes provides a very interesting thing here. Kubernetes is the new de facto infrastructure consumption API. This is how people consume compute, consume networking, consume storage already. Right? And also they consume cloud resources the same way. It's a nice abstraction layer and it's very extensible. It allows you not to worry about stuff that sits underneath. And the cool thing is that because it's used everywhere, there's a whole cottage industry and a huge ecosystem of tools that help you operationalize this. They're like, like observability, debugging, various DevOps, SRE tools. And all this stuff is mature and used by like hundreds of thousands of people. And that's a big deal. And in that world, being standard and de facto and open is a lot more important than being specialized, proprietary, and having like secret add-ons or value adds. And if you look at the Kubernetes ecosystem, it's insane. You should go talk to the cloud native booth people. They'll tell you. So what do we take Kubernetes control and adapt it to SONiC in a way that is acceptable to networking and turn a bunch of SONiC-capable devices into an open fabric that kind of feels, operates, behaves, and integrates in a way that normal Kubernetes does. So which means that this stuff can work with all the same tools and can fit operationally into any Kubernetes environment by just dropping in. So what it looks like is basically you turn the network into a Kubernetes cluster. So you run kubelets on all of the nodes, like you can run it in smart NICs, you can run it in like normal service nodes or processing nodes. You can run it in the switches. And you can have some control nodes where they basically run the Kubernetes master nodes. It can be like in the switches or can be like in a ruggedized NOC or anything. Like anything that can have CPU and memory. And on top of that, to reduce the complexity, you have an open fabric operator that defines a nice model that will help people reason about networking in a way that is not too dissimilar to how people think about VPCs and then AWS. And at the same time, because no two environment is the same, you need to have a set of policies that would govern how those policies and abstractions are translated to actual configuration. So for example, like, if you, let's say, want to isolate each cluster, each Kubernetes cluster in the network, do you want to use BGP VPNs or you still want to use VLAN? Like, that all depends on the circumstances, and that should not influence how the user is configuring the VPC-like construct. Instead, they should be abstracted away from those decisions, because person like trying to allocate a chunk of a network should not think about like VLANs or BGP VPNs, or should not be thinking about VXLAN and things like that. That's kind of travesty. Like, people don't like this kind of infrastructure. So the fabric model has several parts. There's a fabric model that describes conceptual network consumption, topology, various parts, protocols. There's operational model for like the software and configuration, and the service model for how to roll out various network and operational services. Because it's Kubernetes, you can deploy anything, but again, you need to be able to do that as an extension of the fabric model itself. So fabric models, like, they don't have to be all the same, right? Like there's no way to build something that sort of like one size fits all type of way. So you can have something that's VPC-like, like what I described in case of kind of like trying to be like Amazon. There can be something that's optimized for Kubernetes. It can be just a simple normalized network model. There's nothing wrong with that. There are environments that do that. Like there might be another specific model for doing VMware data centers, or like you want to mimic some other ways of abstracting the network. Abstractions could and should be layered. For example, the VPC-like thing can sit on top of the normalized network model, which is a base model that describes, network in its sort of original form without the abstraction. And then you do, at a controller level, you do the translation between the two models. And then the normalized network model basically is what's being deployed at the boxes. Okay. With Kubernetes, it's actually kind of cool. You have the provider operator in the fabric that talks to the fabric consumer operator. So a fabric consumer operator is a Kubernetes operator that plugs into the application cluster and looks at the state of all things networking. So it looks at CNI, service mesh, ingress, egress, security, and looks at various annotations, both within the cluster and the pods that are running within it. And this information is digested and applied to the configuration of the fabric. So for example, like I create a new cluster, automatically you allocate a sandbox for it. And once you have certain pods that are annotated a certain way, you automatically provide routing across multiple clusters and even within the same cluster. Like this way, a person who is running Kubernetes cluster doesn't have to deal with networking really. All you have to do is like do what normal Kubernetes people do, and physical network would converge on the state. And because it's driven by policies and their validations, you always achieve the state that you really want to achieve, and without like much error. And Kubernetes network model is actually fairly simple, and it has like fairly straightforward annotations that we can translate into our configuration. Another thing that Kubernetes gives you is like there was an early talk about Nefio, which is a kind of automation / control plane for running specifically edge applications. And the way it works is basically you drop in operators into the Kubernetes cluster. We're a Kubernetes cluster. So we can natively work with things like Nefio or crossplane. And you basically deal with it the way you deal with normal Kubernetes clusters. You don't have to do anything special or bespoke. So network all of a sudden becomes just another application. Like you don't have to deal with it in any different way. That I think is a big deal. So how do we get there? Obviously, lots of things to do. We need to get Kubernetes to be adapted to networking. Kubernetes was not designed to do a lot of these things. Like for example, Kubernetes requires that the master nodes are always up, or you have like connectivity to them. If they go down, you can only survive for like whatever the timeout is. So that needs to change. Kubernetes needs to be stripped down. Believe it or not, Kubernetes has not been around for a very long time, but already accumulated quite a bit of technical data and baggage. There are a number of distributions that try to address that, namely like K3s is the most popular one. So we are going to be using K3s as a foundation and strip it down even further and evolve the behaviors that would allow to each subordinate node to basically run independently without having masters around. Then another important issue is what happens if like the cluster fails or comes apart. So you need to have fail-safe operation and various config fuses. So what I mean by that is if, let's say, all of a sudden I stop seeing my Kubernetes controllers and I stop seeing other nodes maybe, I should be able to go back to a safe config, right? Like something that I knew worked before. And it needs to be done, and like you switch to the new config, you reconfigure yourself, you recover the state, and then you try the conversion to the next state. That's a very important thing because like in the world of Kubernetes, like if you look at applications, yeah, sure, like you kill a couple of nodes, it's like nothing terrible is going to happen. But in the network, you kill a couple of nodes, like a couple of racks can go away. So we need to try our best not to do that. We need to create fabric model operators. So basically exposing not only the normalized model of the network, but also provide set of abstractions. We need to have a way of inserting exceptions into the configurations. So this way, we can override some of the policy stuff with actual configuration. So like, let's say something is host, you should be able to insert something in line so you can fix the problem. Because like abstractions are great when they work. When they don't work, like you end up with plenty of pain. We need to decide how to create and fit additional services. Like for example, like let's say I want to run a cloud gateway in this Kubernetes cluster. Like how does it extend the fabric? So like a lot of this stuff needs to be designed. And more mundane things like ZTP updates. And then there are painful things, and this is already kind of being like done. Like Kubernetes, SONiC was built with like good intention. I guess like Docker was a big thing in the container world. Now Docker is kind of a cuss word. Like it's not even officially supported by Kubernetes. I mean, it works, but Docker is pretty bloated, complicated, and somewhat extremely buggy. So we should switch to something that's a bit more reasonable, which is containerd, and Docker is now based on containerd. It's like a lot more streamlined. It's not as bloated, and if you want to have like similar experience to Docker, you can use the nerdctl, which is basically a client command line that looks very much like Docker's command line. Then there are like other things that we need to clean up. The way SONiC started was like really clean, I'm sure, and like they're like, oh, okay, well, I can use containers to have like this amazing modularity, and then like it was amazing and too amazing, and then it like ended up with a bunch of bash scripts that are running at the host, and they all have like crazy interdependencies, and there's a lot of boilerplate and content pasting inside that. So that's kind of like wrapping a lot of like Docker run with like some complicated stuff, and like nobody knows like what it's for, and like depending on who you ask, like they'll give you a completely different answer. But like pulling one thread like basically unravels the whole thing. It's kind of complicated. So what we need to further modularize things. So we need to separate the service containers, like for example FRR, and then separate the scripts for like initialization, recovery, upgrade, downgrade, shutting down, like cleanup, into utility containers. And all those things need to be separately updatable. Because, I can have a problem in the initialization script. I don't have to update the entire OS to just fix the problem there. I can have a problem in upgrades and downgrades. I should be able to do that. And all this stuff needs to be described by a very concise config file. You should basically have a list of things that you need to boot and with some notions of order and dependency. And then you have the service lifecycle controller. It basically it's a small agent that picks up the init config file and runs things for you. It can be completely generic. It should be. And it also can be implemented with Kubernetes. Right? It's just another controller on the Kubernetes. Or it can be a standalone agent. It's a fairly straightforward thing to implement. So let's get started. Questions?
Are you also using container D for building the image or just?
You can still build it in Docker. It will run.
Okay.
Yeah.
And do you guys have any metrics or data points that shows before and after using container D compared to Docker? If it's save some memory or
Saves a lot.
So do you guys have some data points? Oh, you don't know. Okay. Okay.
You can look it up.
Okay.
There's information.
Okay. Thanks.
So I'm trying to make sure I understand. So Kubernetes can, in this example, manages multiple layers. First layer, the container layer, if you want to update your containers. But can you speak more to the configuration level? So for example, your routing container, FRR. Are you using, how would you update FRR in this example?
So FRR is a strange piece. So first, let's assume that FRR stays the same and we're not performing surgery on it. I'll talk about the surgery a little later, but it's basically just a piece of code that's a container, so you should be able to update it, right? So there are two things that goes into update, right? There is swapping out of the image. Another one is running the upgrade downgrade script because you might have certain data mutation or schema mutation, so you have to adapt to that, right? But just because you're updating FRR doesn't mean that you have to flash out kernel together with it, right? Or you should not be updating other stuff. So we really want to have images that are not monolithic and sort of composable on the fly.
So you would, today, let's say you either use the configuration DB or you use the ETY interface, what have you?
Yeah, so
You have to modify it to be a little bit more independent?
you're still going to have the database, right? We're toying around with several things. One is using JNMI, right? Because that works pretty well. Although again, there is an overhead because you're basically using an RPC mechanism that's not particularly light. Or maybe writing directly into the database. This is because we have the metadata. So for us, doing that translation is actually pretty simple. Make sense?
You mentioned GNMI, but then where is Kubernetes? Because I thought the idea was to use Kubernetes APIs to control the config, and now you're saying that probably you are going to use GNMI.
So, good question. We want to use JNMI locally just as a stopgap measure because ideally what we want to do is we want to write directly into config database and read from the config database. And then because we have metadata, we can marry models together.
And then the Kubernetes APIs after the GNMI, or?
So either Kubernetes APIs sit on top of JNMI, or we interact directly with the database and the processes.
So I think that generally the idea is going to be that, as Mike had mentioned, there is a normalized model, and then there you have basically the top level model. So when you basically have the normalized model talking to SONiC, you might be using GNMI to talk to it.
Yeah.
And today, as you were talking about VTYSH or the config-DB, there is a unified management framework that Broadcom has contributed to SONiC. That actually brings in all the OCE and data models, as well as the GNMI and the REST interface as well, to control FRR. So you guys can basically do that as well.
Yeah. So again, in the beginning, it's easier to do on top of GNMI, which is simpler. But the eventual goal is to basically interact with as low level as possible. So you eliminate the number of steps, and you increase efficiency and throughput. Because we don't want to introduce another set of bloat.
Then you're going to have application in the Kubernetes cluster going to the same devices from this same Kubernetes, right? The same devices going to the GNMI interface to start.
Yeah, locally. But the only reason why we want to start there is because it's just cleanly defined. That's all. Yeah.
Thank you.
So how hard it is to manage the init config for the container itself? I mean, for example, I had an issue with the FRR image because the FRR image wasn't mapped to the host image. I wasn't able to monitor the PGP. So I had to go change the config and then restart the Docker process, and that actually basically restarted all the Docker images and the blocks.
Yeah. So we need to make sure that we have understanding of the dependencies, and if things need to be rebooted, we need to have a hint of what requires to be rebooted in which order.
But is it going to be easier in container D to do these type of changes if you want to change, for example, the script that actually is trying to run the image for the container? Is it easy to basically do that, or is it going to be the same as Docker?
So I think the challenge is not necessarily Docker. It's all of the harnesses that are written around that.
So, for
Right.
example, if you want to update basically the FRR container, so you have to basically go to the config, say, hey, this is the image ID for the new
Yes.
container. So again, if you want to do that, then you have to basically go through the config file, and then you restart the Docker process, and then it's going to restart everything.
So you will know at compile time, right, or at the image assembly time, which things depend on what. And you will have the instructions of if I reboot this, what else needs to be restarted.
Basically.
Well, if it's everything, then everything, right? But in general, at some point, what we need to do is we need to take FRR and break it up, because it can run in there is no reason why it shouldn't be running in multiple containers.
Right. But I mean, my use case was not related to FRR itself. Any container that you have, for example, SNMP. If you want to update the SNMP Docker container, then you have to go to the config file for the container, change the image ID to the new one.
So that's done internally, right? So you don't have to do it manually.
Yes.
Yeah.
I want to know if this is actually better in container compared to Docker.
Whether it's container D or the advantage of container D is just smaller, right? That's the point. We want to get rid of bloat and security problems. That's all.
Okay, so I understand what Mike is saying. So is it going to be easier to manage individual Docker containers compared to where it is today? So when you have to update something, it affects a lot of containers
Yes.
unnecessarily.
So we want to avoid that, right? So that's an aspirational goal. How far we can take this and how practically implementable, we'll find out. But the goal is to make things modular and kind of when you touch something, you shouldn't be rebooting everything. Yeah.
Yeah, I was looking mostly for to see if this is the case for everyone, or if there's a broken application so that Docker will stuff basically. But if it's, this is for everything, then
Yeah.
Is it something that we're just doing wrong, or is it
No, today it's a closely coupled system, right? So.
so
Like, so we want to modularize it and make it like less coupled. But certain things like, like, I don't know what would be a good example. Like, for certain things, you need to reboot other things. But like, we need to do it by like prescribing the recipe rather than like kind of like doing it coincidentally.
So when you guys like mentioned like managing the Docker images through Kubernetes, so what type of management are you guys like talking about? Like,
So updates, for example,
just
rolling out updates, yeah, like sending configuration changes.
and those are going to restart like all the
Yeah, and or like even like, let's say you want to run like an alternative routing stack. You don't want to use FRR, right? But you can push it out. Like it's a Kubernetes application. I mean, containerized application that you can run anywhere.
deploy like a new Docker image.
Yeah, like for example, like let's say you want to run Arcus, right? So because we're basically looking at this like there are a bunch of computers, right? We'll like deploy software and configure it, and insert probes to like test that it works. That's basically the goal. Any other questions, folks? Yay.